Okay, this is section 5.3. We're going to talk about double angle formulas this time. These are also just on your salmon sheet on the left side, about halfway down. What I'm going to do just one time, I'm going to show you, I'm going to derive a formula from an identity for just the sine double angle formula just one time, and this will be the only time I do this, and then hopefully after this you'll just believe me. So sine 2a, that's the same as saying sine of a plus a. I hope you agree with me on that. And then that's more or less a sum identity, right? So I could say that sine of 2a is equal to, and if I go to my sum identity, that's like saying sine of a cosine of b, but in this case it actually is your a, plus, and then it's cosine a sine of b, but I'm going to rewrite it with a because it's a plus a. All right? And what do you guys know about these two things? Notice they're both the same. So I could just rewrite this as sine a cosine a plus, you can flip-flop them, sine a cosine a. Notice it's the exact same thing, so that's like saying 2 sine a cosine a. Well, if you guys look at your double angle formula, that's the exact same thing. It's 2 sine theta cosine theta. Okay? So that is why or how it works. That's called deriving a formula. This is the one I just did. You could do the exact same thing with any of these, okay? Just a note that there are 3 cosine double angle formulas. It does not matter which one you pick. Sometimes one's easier than the other depending upon the problem. Some of you are going to use the exact same one every single time because you're comfortable with it. I don't really care, okay? Whatever works for you, do that. And then here's your tangent double angle formula. Now there are quite a few slides. I'm going to do the best I can to not make this as long and mundane as possible. Okay? So once again, sine double angle. If I ever ask you to do that, what I would do is I would write down my double angle formula. So go to your salmon sheet. Double angle formula is 2 sine a cosine a. And you can interchange the variable with a or theta or whatever is given in the problem. Okay? So all this saying is that sine a is negative 4/5 in quadrant 3. You're going to want to draw that out. Quadrant 3. Here's my a. Sine is negative 4 over 5. That makes this one negative 3 using Pythagorean theorem. And now you just dump it in again. It's a plug and chug type chapter. What is sine a? Well, they give that to you. It's negative 4 over 5 times, what is my cosine a? Negative 3 over 5. And then you just simplify. So on the top you have what? 2 times negative 4 is negative 8 times negative 3 is positive 24. On the bottom is 1 times 5 times 5, 25. So the double angle is 24 over 25. Okay? I'm going to do the exact same problem, setup, but I want to do cosine double angle. Okay? So if I have the exact same setup, so I have the exact same drawing as last time, but I want cosine 2 theta. Now you have multiple options. If you go to your salmon sheet, you have 3 options for that cosine 2 theta. You don't even need a picture because notice I'm given sine. Let's use the one with just a sine. Okay, that's like 1 minus 2 sine squared a. Okay, all that's saying is that if you know sine a, you just square it, times it by 2, and then subtract it from 1. So 1 minus 2, and I'm going to go in parentheses. What is sine a? And then I'll square it. Sine a is negative 4/5. Sweet. So now I can go 1 minus 2. Negative 4 squared is 16. 5 squared is 25. If I times that by 2, it's 1 minus 32 over 25. And then 1 minus that, this is like saying 25 over 25. 25 minus 32, negative 7 over 25. Okay? Easy peasy. So you just got to find the one, and you would get the same answer if you picked any other one of those cosine double angle formulas. Okay? I purposely put this one on here first, even though we haven't done it. If I give you cotangent, how do you go from cotangent to tangent? Okay? So if you look at your tangent double angle formula, it's 2 tangent theta over 1 minus tangent squared theta. Well, cotangent is the reciprocal of that. Okay? So what I'm going to do, instead of going the 2 tangent a on the top, you put the 2 tangent a on the bottom. And then the 1 minus tangent squared a goes on top. Because it's cotangent, you just flip them. Okay? So that's why I'm writing it that way. And now we just got to dump it in. Now it's the same drill. It's the same idea. So if I go back and draw this picture again, -4, 5, -3, tangent A in each instance will be +4/3. Okay? So all you got to do now is dump it in your formula. 1 minus, tangent A is 4/3, but I need to square it on top, over 2 times tangent A on the bottom is 4/3. And now it's just a matter of simplifying once again. So you could, I like doing the common denominator thing, so that's just kind of my deal. I don't know why. I'm weird. Just go with it. Over, what is that going to be? 8/3. So I have a denominator of 1 and 9 and 3. Okay? 9 goes into all of them. So I'm going to multiply every one of these things by 9. Okay? So then I would have 9 minus 16, because the 9's cross. 3 goes into 9 3 times, over 24. So I'd end up with -7/24. If you guys want to, you could combine the top separate and then do the bottom and then flip it, whatever you need to do, but in the end it should be -7/24. Okay? All right, what do we have now? If cosine x equals 1/√5 with x in quadrant 4, find the cosine double angle answer. Alrighty, I know something about cosine. It's in quadrant 4. I don't even need to draw this one, because is there a cosine double angle formula in which you only have cosine in it because I'm given that? There is. I believe it's the middle one. So if we say that this is equal to 2 cosine squared x minus 1, x and theta can be interchangeable, okay? The reason I'm using this one is I'm given cosine. I don't even need to draw a picture. All I have to do is dump that in, okay? I'm all about doing what is the easiest given the information in the problem, okay? I know cosine right off the bat. I can just dump it in. I square it, which is just what, 1/5 minus 1. And then I have 2/5 minus 1. So 2/5 minus, and if you think about this as 5/5, 2 minus 5, -3/5. Winner, winner, chicken dinner. All right, let's keep on rolling. What if I do the same problem but sine double angle? Okay, once again, you dump it in. I know that sine double angle is 2 sine x cosine x. Okay, now you might need to draw your picture. Quadrant 4. This is 1. This is √5. 1 squared plus something squared is √5 squared. That's 4. So it's plus or minus 2. Which one is it? -2, because it's down. Okay. Now you just got to dump it in. What do we want to put where? Okay, so I go 2 times, what is sine? -2/√5. Times cosine, we already know is 1/√5. And then you just multiply them all together. 2 times -2, -4. √5 times √5 is 5. Once again, then you basically just plug it in and figure it out from there. Okay. What if I give you tangent? Does that matter? Hopefully not. You just got to recognize where we're going and then pick a formula and go with it. So I know I'm in quadrant 3. So here's my triangle, quadrant 3. Tangent is 4/3, but what you got to recognize is we are left and we are down. Both of these are negative. Okay? And then that's 5 there. Cosine double angle. Let's use one we haven't done before. So the only other one that I haven't shown you is cosine squared theta minus sine squared theta. Okay? Do I know both of these in this triangle? Yes, if I go each separately. So cosine is -3/5. So that's -3/5 squared minus -4/5 squared. What you need to keep in mind now is -3 squared is a positive. So each of these inside turns positive. So it's going to be 9/25 minus, this turns positive, so 16 over 25, and then 9 minus 16 is negative 7 over 25. I just wanted to show you one of every type of example that I possibly could. Okay? What if I do secant double angle? Okay? This is the exact same problem as the previous slide, right? What do you guys know about cosecant and secant? If I give you this scenario and you have an answer already, please just flip it. Okay, it's just taking your formula and flipping it. So the actual answer is negative 25 over 7. I'm not going to waste any more of your time. Take any one of these formulas, put 1 over that formula, or just get the answer with cosine and then flip it. Okay? Okay, here we go. Use exact values to show that each is true. If I'm just showing you, you guys just need to actually solve each of them separately. Okay? So what is cosine of 60 degrees? We know that that is 1/2. Okay? Equals 1 minus 2 times, what is sine of 30? Okay? Sine of 30 is also 1/2, and I'm going to square it. Okay? So let's just show this. Well, 1/2 equals 1 minus 2 times, what's 1/2 squared? 1/4. 2 times 1/4. It's 1/2. 1 minus 1/2. 1/2. Okay? To get full credit, you guys do need to show that each of them is that way, but that's kind of the idea behind it. Okay? Not overly hard, just dumping in the stuff that you know. Okay, so sine of 90. What's the y value straight up? We know that's 1. So I got to show that this part is also 1, or a double angle of sine is 1. Okay? So it's 2 times, what do you guys know about sine of 45 degrees? Root 2 over 2. Cosine is also root 2 over 2. All right, so that's equal to, on the top, I have 2 times root 2 times root 2. Well, root 2 times root 2 is 2. Times 2 more is 4. 2 times 2 on the bottom is 4. That's 1. Sometimes they can be that simple. Okay? Simplify the following. All right. What do we want to do here? What you got to be able to do is recognize what scenario we have going on. Which one deals with a cosine squared minus a sine squared? You got to make that connection. Which double angle formula will that be? Or hopefully it gives away that 15. It's going to be a double angle. This is cosine 2a equals cosine squared. All right. I'm recognizing that it's a cosine double angle gives me this. Well, in this scenario, what's my a value? A is the 15 degrees. So I need to just use this. This is us going backwards now. You recognize it's a cosine double angle formula. Cosine of 2 times, what's my a value? 15. So what is cosine of 30 degrees? And hopefully you all know that it's root 3 over 2. Okay? So that's just, you got to recognize that, okay, I have a cosine squared minus sine squared. Let's go to my salmon sheet. Okay, I'm recognizing it's a double angle. I now can dump the 15 in, and then it becomes a formula that's actually useful. Okay? Big typo on this one. Before you can even start, you guys need to put a 2 times tangent in there if it's not already. Otherwise, this just isn't going to work for you. All right? The reason that is you need to be able to recognize which formula is this like. All right, if you go to your salmon sheet, the tangent double angle formula would work, but it has to be 2 times that. If that's not there, you actually can't use anything. Okay? So that's just a typo by me. You need to have a 2 there. As long as the 2 is there, it takes the tangent to theta, or tangent double angle look. And as long as you have that, what is my a, or theta? Maybe I should say theta. The 3 pi over 8 can go in there. Okay? So I'm going to go tangent of 2 times 3 pi over 8. All right? That's like saying tangent of 6 pi over 8, which is tangent of 3 pi over 4. What's happening at 3 pi over 4? 3 pi over 4, that's right in the middle. 1 square root of 2, because this is a pi over 4 reference angle. and it's just that this one's negative. So my actual answer will be negative 1 over 1 because I'm looking for tangent of 3 pi over 4. Okay? This is the last one. This is the doozy. All right, I'm going to do the best I can to go as quickly as possible. You will maybe perhaps see this at some point in time in the near future. Okay? I need to show you that this equals that. So we're going to make cosine 3 theta. You guys don't know anything about a triple angle. So what we're going to need to do is change this to a sum of a double angle plus a single angle. You guys agree that that's the same thing? Hopefully you do. And now I can go, and now I'm going to kind of jump back a couple sections. Cosine of a sum. All right? That's going to be like saying cosine 2 theta, or cosine A, times cosine of B, minus sine of A, sine of B. Okay? And now we can't have any double angles. So I know that the double angle is going to need to go. So I'm going to change both my double angles into something. And you can kind of pick whatever. I don't know which one, honestly, would be the easiest, but I'm going to just write, I like this one better. So I know my cosine double angle would be cosine squared theta minus sine squared theta. Cosine theta minus, what do you guys know about sine of double angle? You only have one option here. Now this option could be changed, so you might be able to get to your answer in a lot swifter move. I can't have parentheses, so I'm going to have to distribute. So that becomes cosine cubed theta minus sine squared theta cosine theta. And then minus 2 sine squared theta cosine theta. And what do you guys notice about this? They're the same. It's like a minus 1 of something, minus 2 of something. So that's going to go cosine cubed theta minus 3 sine squared theta cosine theta. Okay, we still can't have cosine squared though. What do you guys know about cosine squared? All right, I know that cosine squared using our Pythagorean identity is 1 minus cosine squared. Now if I multiply all of this fun stuff through, cosine cubed minus 3 times, I'm going to go this way first. That'd be a cosine theta minus cosine cubed theta. And now if I distribute in this way, this is a minus sign. Okay? That equal sign shouldn't be that. That actually shouldn't be there at all. Minus 3 cosine theta. It ends up being plus 3 cosine cubed theta. And why is that neat? Because 1 and 3 more ends up being 4 cosine cubed theta minus 3 cosine theta. Thank goodness we win. Okay? It's all about practicing, all about knowing your identities. We are obviously going to practice these a lot more in class. That is the assignment we are going to do. And I hope you all have a great day.